Welcome to Energy Basics. Today we're talking about the relationships between potential energy of gravitation, kinetic energy, and potential energy of elasticity in terms of a tennis ball, and why things don't bounce up to the height they were dropped from in terms of energy. After we've described the relationships, we will do a problem involving some of these different types of energy. Let's start off by stating we're dealing with a tennis ball at near Earth's surface, and that for this demonstration, air resistance is negligible. The potential energy of gravitation is highest just before the ball is dropped. In terms of the bank metaphor, we have all of our money, aka joules, stored in the bank. It's here. As the ball falls, the potential energy of gravitation is turned into kinetic energy. We gradually are withdrawing money from the bank and pretty much holding it in our hands. The moment before the ball hits the ground, the kinetic energy will be at its highest, and potential energy of gravitation at its lowest. This is the fastest the ball will be moving, and we have essentially emptied our bank account and are holding all of our money. The relationship between potential energy of gravitation and kinetic energy is that they are inversely related. This moment has passed, and now we're putting money into a different bank. This one happens to be potential energy of elasticity. The ball is compressing, and what was formerly kinetic energy is being quickly turned into potential energy of elasticity. We took our money out of the Bank of America and just put it into Fifth Third Bank. The shape of the ball will then work to reach its equilibrium state of spherical and will turn its potential energy of elasticity into kinetic energy again. It's here, going from that step to that step. And very quickly, I might add, the kinetic energy after the bounce will be at its highest just after it leaves the ground. We have just poured all of our money out of the Fifth Third Bank account. As the ball continues upwards, the joules, or money, are being made back into potential energy of gravitation until all the kinetic energy after the bounce has been turned into potential energy of gravitation. That's seen here. We will notice that the ball is not actually bounced up to the original height. This was because it's not a perfectly elastic collision. When the ball hit the ground, energy was lost in the form of sound. Metaphorically, maybe you bought the Justin Bieber Christmas album while you were putting your kinetic energy money into the potential energy of elasticity bank. Also, some of the molecules at the impact side of both the tennis ball and the ground were heated to thousands of degrees Fahrenheit. Therefore, energy was lost in the form of heat and light, aka it was cold and dark outside, and you're making a deposit. While you're making the deposit, and you bought a coat and a flashlight. Now for the portion where we do some physics type math. We're going to start out doing potential energy. We're going to calculate the potential energy of gravitation for a 1 kilogram object held at 20 meters in the air with an acceleration due to gravity of 10 meters per second. Air resistance is negligible here. For this formula, we will use PE of gravitation equals mass times acceleration due to gravity times height. We have all of our measurements, so you can just plug them in, and you should get 200 joules of potential energy of gravitation. Now, the relationship between potential energy of gravitation and kinetic energy is inverse, but due to the fact that energy is conserved, we should have the same amount of kinetic energy just before the ball hits the ground as we did potential energy before it was released. It can be seen here. The mass is the same, and it is well known that it takes an object to fall from rest 2 seconds to fall, going from rest 2 seconds to fall 20 meters with an acceleration of gravity due to 10 meters per second. This means that after 2 seconds, it will be moving 20 meters per second. So we now have enough information to be able to plug into the kinetic energy equation of 1/2 mass times velocity squared. And again, we should get a kinetic energy value of 200 joules, which is equal to the 200 joules of potential energy. We know that the ball would not reach the same height after the bounce, but we don't know exactly by how much because it's much harder to calculate because we don't know how much energy was lost in the collision. That's it.